This introductory video was created to help you, the new user, understand some basic principles behind Xzibitware. Once you know these, you should have no problem catching on to how different program features work. You can expect to have a shorter learning curve, and you'll be able to take greater advantage of Xzibitware as you prepare your exhibit drawings. We'll begin with AutoCAD block symbols. Since they serve as the foundation for the design and operation of Xzibitware, let's take a moment to discuss block symbols, symbol attributes, and how Xzibitware uses them. Xzibitware makes use of block symbols to represent exhibit parts, things like posts or uprights, rails or crosspieces, counters, panels, beams, chairs, custom parts, and so on. Block symbols provide large time savings since once they are created from different entities and stored as a disk file, they are available to use over and over to create CAD drawings very efficiently. Xzibitware takes advantage of the fact that block symbols can also include a set of attribute entities. Attributes are important because they can hold information entered by the user. This information can also be read by a computer program. Each attribute entity has its own name or tag to identify it. Each one may also include a default value and a prompt string. An example of this might be an attribute used to store color. The identifying tag might be color, with a default value of silver and a prompt of enter metal color. All of the exhibit part block symbols used by Xzibitware include a predefined set of attributes, each with its own name, default value, and prompt string. Let's take a quick look at some attribute entry forms in Xzibitware that allow users to view and change the values held in attributes. This will also give you a chance to see exactly what attributes are contained within a block symbol used by Xzibitware. You will notice in a moment that Xzibitware separates symbol types by placing them into categories. These categories are selected by the user. There are 4 primary categories of parts. They are metal, panel, accessory, and other item. The 4th category, other item, is for any item that doesn't seem to fit in any of the first 3. Here's an attribute editor for metal items. Here's the attribute editor for panel items. This is the attribute editor for accessory items. And this is the attribute editor for other items. Most of these attributes hold information about parts that is considered dynamic. That is, it's subject to change. Here's an example. In one drawing, an 8-foot high post or upright might be colored silver and is rented by the client. In another drawing, that same 8-foot high post might be powder-coated red. It also might be sold to the client because the slot had to be cut into the side. The note attribute for the first post might not contain anything at all, while for the second post, the note attribute holds text that says cut slot per detail 10. At this point, you may be wondering who sets up these attributes in the first place. Well, it's the user. Who else knows what category of part a symbol represents? What part number will identify the symbol? What color should be reported for the part by default, and so on. To make sure that each part symbol contains the correct attribute set, Xzibitware provides a feature called Block Builder. Block Builder is used to categorize parts and automatically attach the correct attribute set while building a block symbol from user-selected entities. It is the user's responsibility to categorize each part and to select the correct entities for the block symbol being built. As part of the building process, the user will also create a data table record for each part when prompted to do so. These records will hold additional information about each part. This will be described further in just a moment. Block Builder is actually very easy to use, and a large library of part symbols can be built fairly quickly. You may be asking yourself why data table records are needed at all. Why not rely entirely on symbol attributes? It's simple. It would not be practical to store cost information for a part within an attribute. If cost ever changed, and that happens often enough, would a user want to go back through dozens, maybe hundreds of old drawings that he or she reused from time to time just to change the cost attribute value in certain block symbols? Well, of course not. If a part description needed to be changed or a part's catalog number, this could also present a problem. Xzibitware gets around this by storing some of the part information in data tables. Item part number, length, height, weight, cost, and description are some of the fields of information kept in these records. This is far more efficient. To change the cost for a particular part, the user only has to change the cost value in the part's data table record. Then, every drawing that uses that part will automatically have a new cost value reported for that part when the drawing is examined by Xzibitware. As mentioned earlier, most of the information kept in attributes is dynamic, or subject to change, based upon how a part might be used. Exceptions to this are the attributes that hold a symbol's part number and its part category. The part number attribute is used to link a symbol with its matching record in a data table. Part numbers can be up to 18 characters in length. To work with the different categories of parts found in exhibit drawings, Xzibitware uses more than one data table. Each table holds information for a specific category of parts. This means that additional data for posts, beams, crosspieces, and trusses, for example, should be kept in the metal data table. Additional data for panels should be kept in the panel table. Additional data for items such as end caps, end plates, base plates, tension lock adapters, inserts, hinges, and brackets, for example, should be kept in the accessory data table. And additional data for items such as shelves, countertops, literature stands, doors, turntables, and assemblies, a counter assembly, for example, is usually kept in the other items data table. The user is not locked into categorizing his or her parts this way. These are merely suggestions. Now let's see if we can understand how Xzibitware gets information from block symbols and data tables. To get the information it needs, Xzibitware provides the extract data command for the user. The command may be used repeatedly and at any time during the drawing creation process. Extracting data involves going through an exhibit drawing from start to finish. Some users think of this as scanning or mining a drawing for data. As it goes through a drawing, Xzibitware saves data it finds in any block symbol that contains an Xzibitware part category-specific attribute set. All other blocks are ignored. The most important attributes Xzibitware attains in this process are the part number for each symbol and its part category. From the part category value, Xzibitware knows which of the 4 data tables it should search to get the remaining information it needs. After opening that data table, Xzibitware searches for a record with a part number field value that matches the part number attribute. If it finds a record match, it grabs the record's contents so it can be reported later along with symbol part attribute values. Besides gathering information, Xzibitware also groups identical parts together, looks at size and material information for items like panels, some accessories, and other items, and estimates cost for all the parts found in a drawing. This processed data can be seen in a multitude of reports provided by Xzibitware. When Xzibitware was first created in late 1995, it only had 3 goals. 1. help users create exhibit part symbols with attribute sets and store them in a symbol library. 2. Help users create data table records that can be linked to parts. And 3. Count exhibit parts found in drawings and create material list reports about them. In short, Xzibitware could have been described as being a parts library builder and parts counting reporting tool. That began to change in 2003 when MALEKKO completely rebuilt the program. It was understood that it was time to start adding a series of carefully planned, time-saving tools to Xzibitware. Time to go beyond creating libraries, counting and reporting parts. The goal was to create a product that would motivate designers and detailers and managers to want to include Xzibitware when they selected software to use in their work. The requirements for each new tool were straightforward. It had to improve implementation time for a task by at least 100%. The way a tool should be used had to be fairly intuitive to the user. The number of steps required to use a tool had to be held to an absolute minimum. Information from previous use of a tool, where applicable, should be automatically preloaded for the user to speed up operation. If any user error occurred with the tool, a message should inform the user of that error, and the tool should continue to work if possible. To date, a list of the tools we have added to Xzibitware includes the following seen here. Except for AutoCAD Block and Drawing Annotator, these tools not only create exhibit parts much faster than when using AutoCAD alone, they also add needed attribute sets and data records for each part so that they are ready to be reported in a bill of materials list. This concludes our introductory tutorial.